channel. So in this slot, we're going to discuss important forecast questions starting from chapter 1, form 4 until chapter 3, the mole concept and the chemical formula and chemical equation. Right, let me start with the important definition that student must remember. The first important definition that student must remember is state the meaning of chemistry. Chemistry is the word originated from the Arabic word known as alchemia, and the chemistry is a study about structure, properties, composition, interaction between matter. All right, we move on to the second definition. What is meant by melting point? The point that measure here is temperature. Alright, so the melting process temperature or constant temperature at which solid is converted into liquid. So the definition is here. Alright, our third definition is nuclear number. The formula to calculate nuclear number to sum up of protons and neutrons that present in the atom of an element. Student must mention the atom. Alright, so next one, proton number is a number of protons present in the nucleus of an atom. So what is mean by valence electron? The electrons that located in the outermost occupied electron shell of an atom. All right, so we move on to the definition number 6. Most important definition is known as isotope. Isotope must mention atoms of same element. Student must mention atoms of same element which shows same proton number but different nuclear number, or we can use which shows same proton number of protons but different number of neutrons. And please remember to put atoms of same element which shows same number of protons but different number of neutrons. So we move on to the question definition number 7. State the relative atomic mass. All right, definition for RAM. So we try to write down the relative atomic mass. So here I take A stand for average. I take mass of one atom of an element. When we compare with 1/12 times mass of one carbon 12 atom. So the definition is given here. Average mass of an atom of an element with 1/12 of mass of one carbon 12 atom. Alright, state the related definition for the relative molecular mass of one molecule of the substance compared with 1/12 times mass of one carbon 12 atom. So state the meaning of 1 mole. 1 mole means the quantity of substance that contains same number of atoms exactly in 12.00 gram of carbon 12, which is used as a standard atom in determining relative molecular mass, relative formula mass, and relative atomic mass. Alright, so next one we move on to the Avogadro constant, is known as number of particles in 1 mole of substance. Alright, the most important definition is state the definition for the empirical formula. We try to do one example here. So I take compound. Right, this compound is known as glucose. So I try to put the formula of glucose C6H12O6. Alright, this compound called glucose contains 3 elements, which is carbon, hydrogen, and oxygen, and the number of atoms is carbon 6, hydrogen 12, and oxygen 6. Alright, so we try to find simplest ratio. So I try to divide with smaller number, which is 6. So I will get 1 to 1. So the formula, empirical formula, CH2O. So what is meant by empirical formula? Simplest ratio of all number of atoms of, student must put this word, each elements that present in a compound. So I repeat again, simplest ratio of all number of atoms of each elements that present in a compound. The answer is given here. Chemical formula that shows simplest ratio of all number of atoms of each elements that present in a compound. We try to go for last definition, which is a molecular formula. Chemical formula that shows actual number of atoms of each elements that present in one molecule of the compound. Alright, we move on to the next part, self-protecting equipment and safety equipment in the laboratory. Student must remember, okay, this diagram. So here we try to check the self-protecting equipment. Number 1 is laboratory coat. Okay, the coat protect the body from and the clothes from chemical spill. Then we have glove here. So this is a glove. Glove is used to protect the hand from injuries, chemicals, or infection. And safety goggles will be protect the eye from chemical splash and also dust particle. And the face mask is protect the respiratory organ from the chemicals such as powder and also fume. Alright, we try to check this question. Alright, so this question, so what is the function of the personal protective equipment given in the example in the diagram above? So this answer to prevent the dust particle and chemicals getting into the eye. So the answer will be A. So we check question number B, answer number B, to protect the respiratory organ, that will be face mask. Alright, so to protect the hand from injuries, that will be glove. To protect the body, that is lab coat. Alright, so this is the answer. Student must remember. We move on to the next one. Alright, this instrument is known as fume chamber. Fume chamber is used to carry out experiment that releases toxic vapor that caused by the combustion or produce pungent smell. Example of chemical substance that produce toxic vapor: ammonia, formula NH3, chlorine, formula Cl2, bromine, formula Br2, and chloroform. Alright, so we move on to the next safety equipment that student must remember. This is a shower, a safety shower, and eye wash. So this is a shower, right? So this is known as eye wash. All right, so what is the function of safety shower? Is used to wash and clean the body when a chemical accident occur on the part of the body, and also used to extinguish fire on the clothing. All right, eye wash is used to wash and clean the eyes when chemical spill occur on the part of eye or human face. All right, we move on to the next part. That will be under storage and disposal and safety precaution in the laboratory. All right, so under storage, so we try to check the reactive metal. What are the reactive metal? Lithium, sodium, and potassium. Please remember, lithium, sodium, potassium are reactive metal. They must store in paraffin. All right, paraffin oil to prevent the reaction with the moisture that present in the air. All right, so next one, how to disposal method of hydrogen peroxide. Hydrogen peroxide is a colorless solution, the formula H2O2. All right, this hydrogen peroxide with lower concentration hydrogen peroxide with low concentration can be poured directly into sink. All right, we no need to dilute the lower concentration of hydrogen peroxide. And however, hydrogen peroxide with high concentration has to be diluted with water and added with sodium sulfate. Please remember, sodium sulfate for the decomposition process to take place before we pour into the sink. So please remember the procedure. Right, check the diagram given here. So here we have what? Mercury. All right, mercury spill occur. All right, so maybe thermometer break ready. So all these, please remember the mercury spill. So we need to suggest the management procedure whenever mercury spill occur in the laboratory. So the answer will be, we open the window and door to allow sufficient air ventilation and make the spill area as a prohibited. Collect the mercury spill by using mercury collector and sprinkle some sulfur or zinc powder to cover up the spill, and contact the fire and rescue department for further action. So these are the things that student must remember for the first chapter. So we move on to the next one, chemicals and their uses. All right, the first one is sodium chloride. The sodium chloride is made up of ions, which is sodium ion and chloride ion. This common sodium chloride is known as table salt or common salt, and used as a flavoring agent to enhance the taste of the food, and also used as a preservative to prevent the food being spoiled by microorganisms. All right, next one, we move on to the acetic acid or ethanoic acid. Is used as a formula of ethanoic acid, CH3COOH, and this is known as a weak acid. All right, so please remember, ethanoic acid found in used to manufacture vinegar is also used as a preservative to prevent food being spoiled by the microorganism. And next one, MSG is known as monosodium glutamate, is used as a flavoring agent to enhance the taste of the food. All right, the next one, magnesium oxide, the formula MgO, and the magnesium hydroxide, all right, the formula Mg bracket OH2. All right, and this magnesium hydroxide or magnesium oxide is used as antacid. Okay, antacid pill to neutralize the hydrochloric acid or gastric juice acid that produced in stomach. Right, so to treat stomach ulcer. And next one, under isotope. So please remember, isotope is known as atoms of same elements, which shows a same number of protons but different number of neutrons. All right, so this carbon 1214 isotope is used to determine the age of fossil and also ancient artifact. Cobalt 60 is used to destroy or treat cancer cell. All right, in food industry, the cobalt 60 is used to destroy microorganism in food without changing the quality of the food. Iodine 131 is used to detect the thyroid diseases that present in the thyroid. All right, thyroid gland. All right, so please remember, it's used to study or treat thyroid diseases and cancer or diseases. Sodium 24 is used to determine the underground pipe leakage. So please remember, it's used to determine underground pipe leakage. Phosphorus 32 is used to study the plant metabolism, or the metabolism of phosphorus by plant is investigated by using fertilizer that contains phosphorus 32. Try to look at this question. So which of the following isotope is used to detect the underground pipe leakage? So the answer will be sodium 24. And which of the following isotope is in determining thyroid diseases? That will be iodine 131. And we try to check food food technologies. Food technology intends to destroy microorganism or bacteria that found in potato to rot using radioisotope. The radioisotope that you use is cobalt-60. Please remember, in medicine cobalt-60 is used to treat cancer cells. All right, so next one, which of the following is the uses of carbon-14? Carbon-14 is used to determine the age of fossils. So these are the answers that student must remember. All right, so we move on to the next part. Alright, next part will be particles. Please remember, and matter, anything that has mass and occupies space. And matter are made up of tiny and discrete particles, and this particle is known as AIM. A stand for atom, I stand for ion, and stand for molecule. So we try to check when there's a symbol, one capital, one small, one capital, one small, one capital, one capital, one capital, one capital. All this is atom. Atom is known as smallest particles. Most of the atoms exist in solid form. They are arranged in closely packed and in order, and they do not move, and they only vibrate and rotate at the fixed position. All right, next one, when we see molecule made up of non-metal plus one more non-metal. Non-metal plus non-metal, they will exist as molecule. Please remember 5 important non-metal that a student must remember. Please remember carbon, hydrogen, oxygen, nitrogen, and sulfur. Alright, carbon, hydrogen, oxygen, and nitrogen and sulfur. So we check the phosphorus molecule. Please remember P4. Nitrogen gas is N2. Naphthalene C10H8. So non-metal exists as molecule. Sulfur molecule, please remember S8. Alright, so please remember sulfur molecule will be S8. Alright, ammonia non-metal exists as molecule. Ethanol C2H5OH exists as molecule. Glucose C non-metal, hydrogen non-metal, oxygen non-metal exists as molecule. And please remember, most of the molecule exist as gas. If let's say they exist as gas, how to draw the drawing is here, and the arrangement, they are arranged further apart from each other. They collide, collide each other or collide rapidly. Alright, so and the movement of the particle will be they move randomly and collide each other. Alright, and next one, when we have ion. So ion is known as a charged particle. We have two type of ion. Number one is known as cation. Cation means is positively charged ion. So please remember, positively charged ion is known as cation, and the negatively charged ion is known as anion. So please remember, negatively charged ion is known as anion. So please remember, when cation and anion combine together through ionic bonding. Alright, so ionic bonding. So when we have metal plus non-metal, okay, the metal, please remember this formula, when metal plus non-metal, the type of particles present is ion. Please remember the famous metal king, Netto, Catch, Mango, After, Zaret, Fly, Singapore, alright, Purchase, Cute, amine. So these are the metals that student must remember. Sodium chloride, please remember sodium chloride, metal, non-metal, the type of particle is ion. Magnesium chloride, type of particle, metal, non-metal, will be ion. Zinc chloride, metal plus non-metal, the type of particle is ion. Magnesium nitrate, the type of particle, metal plus non-metal, will be ion. Alright, copper 2 sulfate, the type of particle will be metal plus non-metal, will be ion. So most of these ionic compound or ions exist as a liquid. The arrangement of the particle will be here. They are closely packed but not in order. Alright, then they collide. Alright, collide each other. Alright, so and they move throughout the liquid. Alright, so next process, okay, is known as diffusion process. So we try to check this question. The smell of the perfume spread while we walk past the cosmetic counter. Alright, so explain the process involved. Please remember here, the concentration of cosmetic perfume particles is higher, and here the concentration of perfume particles is lower. The movement of particle from higher region of concentration to the lower region of the concentration is known as diffusion. Alright, so here we have air molecule. Air molecule got a lot of empty spaces. So here got a lot of spaces, alright, between the air molecules. So please remember, this perfume gas particle is made up of molecules. They will move randomly. So this is the investigation rate of diffusion in gas. the process, the answer by using kinetic theory. How to explain this process? The process involved is diffusion. The perfume smell are made up of tiny and discrete particles. The perfume gas or smell move randomly and occupy the empty spaces that be present between the air molecule. The perfume gas smell particles move from the region of higher concentration to the region of lower concentration. So all this is very important. Please remember. We try to do few questions here. Which of the following substance exists as molecule? Please remember, molecule must have non-metal plus with non-metal, and try to remember 5 non-metal: carbon, hydrogen, oxygen, nitrogen, and sulfur. Steam is made up of water, carbon, C, magnesium, Mg, sodium, chloride. So carbon, 1 capital, so this is atom, so cannot be the answer. Magnesium, 1 capital, 1 small will be atom, cannot be the answer. Sodium is metal, chloride is non-metal, therefore they exist as ion, cannot be metal. Hydrogen, non-metal, oxygen, non-metal, so the answer will be steam. Right, which of the following substance consists of ions? So please remember, if ions, okay, exist as metal plus non-metal, metal plus non-metal, the type of particles present is ion. So we try to do the formula: carbon dioxide, non-metal, non-metal, exists as molecule. Sulfur dioxide, sulfur, non-metal. Oxygen, non-metal, exists as molecule. Calcium chloride, calcium, metal plus non-metal. So here we have metal plus non-metal, so they exist as ion. So the answer will be C. Hydrogen chloride, hydrogen, non-metal. Please remember, chloride also non-metal, so they exist as molecule. Alright, so the answer will be C. We try to check this question. Which of the following exists as atom? Atom, 1 capital. So we try to write down the formula: chlorine Cl2, water H2O, oxygen O2, and carbon. So this is non-metal. Non-metal exists as molecule. Under element, it will be molecule. And hydrogen non-metal, oxygen non-metal. This particle will be molecule. Oxygen, two same atoms combined together, non-metal, non-metal. Therefore, they exist as molecule, and this will be atom. Alright, carbon will be atom. Alright, try to check this question. Carbon react with chlorine. So when carbon react with chlorine, so carbon is non-metal. Chlorine also non-metal. State the type of particle. When non-metal plus non-metal, the type of particles will be molecule. So the answer will be molecule. So we move on to the next question. So the matter particles and melting process of naphthalene. Please remember, the formula of naphthalene is C10H8, and this naphthalene exists as molecule. Alright, so we try to check argon, 1 capital, 1 small. Try to check the chemical formula: 1 capital, 1 small. Therefore argon exists as atom, and we have naphthalene C10H8, non-metal exists as molecule. And when we have metal sodium combined with non-metal chloride atom, they exist as ion. So state the type of particles present in argon. So the answer will be atom, the naphthalene molecule, and sodium chloride is ion. Alright, state the physical state of sodium chloride at room temperature. Sodium chloride exists as solid at room temperature, and always remember, is used as a flavoring agent to enhance the taste, also used as preservative. And therefore please remember the sodium ion. Sodium chloride is made up of metal plus non-metal, exists as ion. We have two type of ion. Cation will be sodium ion, and the anion will be chloride ion. And this sodium ion and chloride ion are attracted together by stronger electrostatic forces of attraction. Thus we need more heat energy is required to overcome the forces of attraction. Therefore we try to check question number C. Okay, explain why the melting point of sodium chloride is higher than naphthalene molecule. Because the sodium ion and chloride ion are attracted together by stronger electrostatic attraction force. Thus more heat energy is required to overcome the forces of attraction. And we check naphthalene molecule C10H8. Between this molecule, there is a weaker van der Waals forces of attraction. So we have C10H8. Between this molecule, there is a weaker, please remember, weaker van der Waals attraction forces exist between the molecules of naphthalene. Thus, we need less heat energy is required to overcome the forces of attraction. So the answer will be here. Okay, so the naphthalene exists as molecule. There is a weaker van der Waals forces of attraction exists between the molecule. Thus less heat is required to overcome the forces of attraction. So please remember. Alright, now we move on to the melting process of naphthalene. Melting means the solid changing into liquid from B to C. From B to C, this horizontal line, the particles will be in the mixture of solid plus liquid, and this T1 will be the melting point. So please remember, the meaning of melting point is a constant constant temperature where solid changes into liquid. So the answer is given here. State the meaning of melting point. A constant temperature where solid changes into liquid. What is state the melting point? So T1 degrees Celsius. And why the temperature remain unchanged between B to C, the particle in solid state here. So what happened? The heat energy is absorbed when we heated the particle. So here please remember heat energy is absorbed. Why the heat energy is absorbed? To overcome the forces of attraction, so the particles are arranged not in order. All right, so please remember the heat energy is absorbed by the particle to overcome the forces of attraction between the particle, so that solid can be turned into liquid. What is the physical state of naphthalene from melting point? So here the particle will be in mixture of solid plus liquid, and please remember the answer. All right, so if let's say the sodium nitrate, it has melting point of 300 degrees Celsius, so we take a sodium nitrate. The formula of sodium nitrate will be NaNO3. All right, so its melting point is 300 degrees Celsius. So when we heat it, all right, so we must use what bath. So please remember we cannot use water bath, because the boiling point, please remember the boiling point of water is 100 degrees Celsius, which less than the melting point of the sodium nitrate. So I put here thermometer, so we put here sodium nitrate, so this will be NaNO3. The suitable bath will be oil bath. All right, so can we determine the melting point of sodium nitrate by using water bath? The answer, no, cannot. Why? Because the melting point of sodium nitrate is higher, which is 308 degrees Celsius, higher than the boiling point of water. We can use oil bath to replace the water bath. All right, so please remember this type of question. So we move on to the next question. Please check this question. So the melting process. So melting point means before melting point, please remember particle in solid state. Once it's reached melting point, the only after melting point, the particle will turn into liquid state, and the boiling point, after boiling point, the particle will turn into gas. And please remember the room temperature is 27 degrees Celsius, and we need to state the physical state of substance P. The physical state of substance P, so I put the melting point negative 137 degrees Celsius and the boiling point negative 8 degrees Celsius. And the room temperature, please remember 27 degrees Celsius. The room temperature somewhere here, so the particle exists as gas. So I put particle exists as gas. All right, we try to find the physical state of Q. All right, Q, the melting point is negative 12 degrees Celsius, and the boiling point is 44 degrees Celsius. And the room temperature will be somewhere here, so the particle exists as liquid. So I put here liquid. All right, so we move on to the next one, R. The melting point will be 70 degrees Celsius, and the boiling point is 186 degrees Celsius, and the room temperature, which is 27, will be somewhere here, so the particle exists in solid state. All right, then the last one, please remember here I put solid, this is liquid, this is gas. All right, so the room temperature somewhere here, the particle of S will be in solid state. So please remember this type of question. So we move on to the next one, how to draw graph for the cooling process of naphthalene. So when the naphthalene, the liquid molten naphthalene is cooled in the conical flask, it will undergo cooling process. Okay, this experiment is used to determine the freezing point of naphthalene. If let's say the temperature time taken is given, so make sure the time taken will be in axis X, so the temperature will be in axis Y. Where is your axis Y? This will be axis Y, and this will be axis X. So please take the 0, 95. So we take all the data given in the table, we try to plot the graph will be like this. All right, so we try to do one more similar question here. All right, try to check this question. We read together this question together. All right, so an experiment is carried out to determine the freezing point of liquid Z. The boiling tube containing molten Z at 95 degrees Celsius is allowed to cool in conical flask at room temperature to room temperature. The temperature of Z was taken every 30-second interval, and shown in the reading of a thermometer is shown in the diagram below. So we try to read this one. So initial temperature at 0 second. So this will be 95 degrees Celsius. All right, next one will be 90 degrees Celsius. So we put unit together with the unit, and at 60 second that will be 82 degrees Celsius, and 90 will be 80 degrees Celsius. All right, 120 will be 80 degrees Celsius. All right, under 50 also 80 degrees Celsius, and under 80 will be 78 degrees Celsius, and 210 will be 70 degrees Celsius. So we already got the data. Then we try to convert degrees Celsius will be 95. All right, so 30 degrees Celsius will be 85, and this will be 82, 90 will be 80, 120 will be 80, 150 will be 80, 180 will be 78, and 210 will be 70. Right, we try to plot the graph together. So we try to do the title, a graph of temperature against time for the cooling process of substance Z. So here I put temperature, the unit for the temperature, degrees Celsius. Here I put the unit for time, the unit will be second. So I try to draw this one, we try to get the scale here. This will be 30, all right, this will be 60, this will be 90, so 120, 150, 180, 210. All right, so we try to get the scale for the axis Y. So this will be 10. I use 10, 20, 30, 40, all right, 50, 60, 70, 80, and 90. All right, we try to plot the data that are obtained from the thermometer reading. 0 will be 95, so I put here 95, and 30 will be 85. 85 is here. All right, and next one, 60 will be 82, so 82 will be here. All right, and the 90 until 150 will be 80, so here 150, 90, 120, 150. All right, so and next one 180, so this will be 180, 180 we will get 78, so the 78 will be here, and 210 will be 70. All right, so we try to draw the graph. So I try to draw the graph. So this is the graph, and we try to check the next question that they want in the from the question. The physical changes of physical state of naphthalene during cooling process. All right, so please check the time. It exists as liquid. All right, here it exists as liquid from 90, this is 90 until 150. It exists as mixture of liquid plus solid. So here solid liquid. All right, and from 150 until 210 it exists as solid. All right, so we try to put here the answer. So exists as liquid. All right, liquid from 0 second, all right, until 90 second. And second point, it exists as mixture of liquid and solid. All right, from 90 second until 150 second. And last one, it exists as solid, okay, from 150 second, okay, until 210 second. All right, the last question: why was the boiling tube placed in the conical flask during the cooling process of this substance Z? So this is to ensure an even cooling. All right, cooling process is conducted. All right, conducted to minimize. All right, to minimize the heat loss, to surrounding, and to obtain an uniform temperature. So these are the answer that student must remember. All right, please do more question. We move on to the next question. We move on to the next question. So under nuclear number, proton number, and the isotope, we try to check the table given here. K, the proton number is given 8, the number of neutron is given 8 Lm. So these are the atoms that not represent the actual symbol number. All right, so please remember the first question, state the meaning of nuclear number. Nuclear number stand for sum up of protons and neutrons that present in the nucleus of an atom. So must mention atom. All right, so next we go for nuclear number of L. So I try to do the L, the proton number is 11. It has total number of neutrons. So I put here proton will be 11. This is neutral. So neutral proton equal as electron. So 11, and the neutron is 12. All right, so the nuclear number will be P plus N. So the proton will be 11 and the neutron will be 12. So that will be 23. So 11 plus 12 is 23. And we try to do the standard representation of atom M in the format of this. So we go for M, so we put the symbol M. So it has proton, M as proton, 11. So proton 11, and please remember this is neutral atom, proton equal as electron, so the electron will be 11 and the neutron is 13. So we take the proton number 11, we put here, we plus proton 11 plus 23 or 13, that will be 24. So this is the symbol given here. Which of the following atoms are isotopes? So we try to check which of the following atoms are isotope. Isotope, they have same, all right, proton number. They have same proton number but different. All right, different nucleon number. All they have same number of protons but different number of neutrons. M. So this atom L and atom M, they have same proton number but their number of neutrons is different. So the answer will be atom L and M. Please answer the both atom L and M shows same number of protons but different number of neutrons. All right, so we move on to the next one. For E, state which atoms shows the same chemical properties. So atom L and atom M. So I take L, proton number 11, M, proton number 11. We try to do the electron arrangement 2.8.1, 2.8.1. All right, always remember the chemical properties. All right, the chemical properties of an element is determined by using the valence electron. So when these two atoms have same number of valence electron, therefore atom L and M shows the same chemical properties. So therefore atom L and M have same number of valence electron, therefore they show same chemical properties. Now we move on to the second question. All right, write the electron arrangement of atom W. So we check the atom W, so we check the proton number W as proton number 16. So we use the first shell 2 electron, second shell 8 electron. So we minus 10 here. So the balance will be 6 electron will be here. So the answer will be 2.8.6. All right. So please remember the how to do the electron arrangement. All right, so we check question number B. So the electron arrangement of ion X. So how to do the electron arrangement of ion X? First, we check atom X. So atom X, it has 7 proton number. So that means the proton number will be 7. So we try to do the electron arrangement. All right, now we check the valence electron. If let's say valence electron 4, 5, 6, 7. All right, so the atom will form an ion. How they form an ion? An ion means negative ion. How they form an ion? So by accepting electrons to achieve stable duplet or octet electron arrangement. All right, so what we will do, so here this atom has 5 valence electron, therefore it will form an ion. So we put negative, we take the valence electron 5, it will accept 3 electron and achieve stable octet electron arrangement. So we take the 3, we put in front here. So this is the formula of the ion is here. The electron arrangement of this ion will be 2.5 plus 3. We take this one, 5 plus 3, we will get 8. So I put 8 here. All right, so next we move on to the next question. Draw the electron arrangement of atom Y. So atom Y, so we try to do, I erase this one. Try to do the electron arrangement, draw the electron arrangement of atom Y. So before we draw, I try to put find PEN, pen, proton will be 16. This atom is neutral, proton equal as electron. So electron 16 and neutron. So the neutron number of neutron given is 16 also. All right, so 16. So what we do, we draw the nucleus. Inside the nucleus, we put 16p and 16n, and we try to do the electron arrangement 2.8.6. All right, so this is first shell, second shell, third shell. The first shell 2 electron, second shell 8 electron, and the valence shell will be, all right, 6 electron. All right, we try to check this question. Please try to check, we do together this question. All right, what is the meaning of isotope? We can use the definition given in the table, or we can use our own definition. So please remember, we put atoms. Isotope is known as atoms of same elements which shows same number of protons but different. All right, so I put different number of neutrons. All right, so next one, we try to check what is the uses of sodium 24. All right, isotope sodium 24 in daily life. So sodium 24 is used to detect underground pipe leakage. So next we move on to the next question. Sodium 23. So I write sodium 23. So here 23, it has proton number 11. So we check the proton number is 11, the sodium 24, all right, 24, the proton number 11. All right, so we try to check the atom. Always remember proton equal as electron. So number of electron 11, number of electron 11. How to find? We take 23 minus with 11, that will be 12. So here 24 minus with 11, that will be 13. All right, so now we move on to how to find abundance percentage or relative atomic mass. If let's say the percentage of the isotope is given, so we have magnesium 24, all right, magnesium 25 and magnesium 26. So we put the magnesium 24, we put here magnesium 25, and also we put magnesium 26 here, and we try to check the percentage of 24 will be 79.0 percentage, and next one will be 10.0 percentage, and the last one 11.0 percentage. When we total up all the percentage, that will be 100 percentage. And how to find the relative atomic mass of isotope magnesium 24? So I put here RAM of isotope magnesium, so will be magnesium 24. We take the 24 times with 79.0, then we plus with 25 plus 25 times with 10.0. All right, so plus with this one 26 times with 11. Right, 11.0. Then we sum up all the percentage, we will get 100 percentage. So we divide with 100 percentage, so we will get 24.3. So this is the answer, RAM of magnesium isotope. All right, so we try to do another question. All right, try to check this question. All right, this isotope X. So we have isotope X 35. All right, and one more isotope 30X 37. And the percentage of 35 will be 75 percentage, and the percentage of 37 will be 25 percentage. When we total up all the percentage, that will be 100 percentage. All right, so how to calculate the relative atomic mass of X? So RAM of X. So how to calculate? We take the 35 times with 75, we plus with 37 times with 25. All right, so then we divide with total percentage, which is 100. So we will get 35.5. So the answer will be B. All right, move on to the melting process. Please check the diagram given here. The diagram below shows the heating process of substance X, and please remember the melting process solid is changing into liquid. All right, so in this process, we will use water bath to ensure an even heating process is conducted to obtain an uniform temperature. And circle one mistake done in this diagram. So the base of the boiling tube touches the base of the beaker. So this should not touch the base of the beaker. All right, so the graph of heating curve heating of substance X is given, and the substance X is heated from 60 degrees Celsius. So here the particle will be in solid state. All right, so C to D particle will be in liquid state, and from B to C the particle in the mixture of solid and liquid. And the melting point of this substance X will be 80 degrees Celsius will be the melting point. And if let's say they ask why the temperature remain unchanged from B to C, why the temperature remain unchanged, the particle in solid state will be heated during the melting process, so the particle will absorb heat energy. So here we put heat energy is absorbed. Why heat energy is absorbed? So that the particle, the forces of attraction between the particle can be overcome. So the heat energy is absorbed by the particle to overcome the forces of attraction between the particles, so that it can turn from the solid to the liquid state. All right, so we try to answer this question. All right, based on the graph given in the question, state the melting point of the substance X, so that will be 80 degrees Celsius. And what is the physical state of substance X from B to C? Is a mixture of solid and liquid. Why the temperature remain unchanged? Because the heat energy is absorbed to overcome the forces of attraction between the particles of substance X. All right, so draw the arrangement of the particle at 60 degrees Celsius. So if we check the 60 degrees Celsius, the particle in solid state, and from 90 degrees Celsius, the particle in the liquid state. So make sure draw 3 layers. All right, draw 3 layers, and same size of atom, they are arranged closely packed and in order. And this liquid state, they are arranged closely packed but not in order. All right, so look at the question number F. Substance Z, the melting point is 43 degrees Celsius and the boiling point is 89 degrees Celsius. So I put here melting point of substance Z is 43 degrees Celsius, and the boiling point of substance Z is 89 degrees Celsius. So before the melting point, the substance in solid state, between melting and boiling point, the substance in the liquid state, and after boiling point, the substance will turn into gas state. And we read the question, so they need us to sketch the graph of substance Z heated from 30 degrees Celsius. So where is the 30 degrees Celsius? That means the substance Z heated from solid. Alright, so I put here heated from solid, alright, until 100 degrees Celsius. So 100 degrees Celsius somewhere here. Alright, that means the substance is heated from solid until liquid, and liquid goes to gas. So we have two state here. So how to draw the graph? So I label axis Y as temperature degrees Celsius, then I label axis X as a time, the unit will be second. So we have one horizontal line, so I put here the one horizontal line is here, and we have another horizontal line, so I put here another horizontal line is here. The substance Z is heated from 60 degrees Celsius, and this will be the melting point, which is 49 degrees Celsius, and it heated until turn into liquid. So this is the boiling point, which is 89 degrees Celsius, and it will be heated until 100 degrees Celsius. 100 degrees Celsius. So this is the graph that students should sketch, all right, to the answer. So the graph is given here. All right, so we move on to the next one. All right, so read the question. The standard representation of an element allow the information about an element can be displayed in simpler and more accurate manner. All right, so in this diagram, given carbon has 6 proton, 6 neutron. So this is electron, proton, and neutron. So they ask us to write the standard representation of atom in X, Y, A, Z. All right, so the element symbol is carbon. So it has how many protons? So it has 6 proton. Okay, it has 6 neutron, and this atom is neutral, therefore it has 6 electron. All right, so the nuclear number will be proton plus neutron, which is 12, so I put on above, and the proton number will be 6. So this is the standard representation. All right, we go to the next point. Deduce 5 information based on the atom given. So I write the standard representation. So 12, 6. Alright, so first we have to state the element is what. So the first point, the element is carbon atom. Second, we have to mention about the number 6, which is proton number. The proton number is 6. So we have to describe what is proton number. The total number of protons present in the nucleus of carbon atom is 6. Next, we describe the nuclear number. This is known as nuclear number. The nuclear number is 12. Alright, the total number of protons and neutrons present in the nucleus of the carbon atom is 12. Then we do 12 minus 6, it has 6 neutrons. Alright, so I put here there are 12 minus 6, 6 neutrons in the nucleus of carbon atom. And the electron arrangement, we use the proton number to do the electron arrangement. The electron arrangement of carbon atom is 2.4. Alright, now we try to check another question. Carbon 14. Carbon 14 is the isotope of carbon 12. Alright, carbon 14 is the isotope of carbon 12. Compare and contrast both atoms. When they give compare and contrast, please write one similarity and give the, say they ask us to draw how to draw the carbon 14. Please remember carbon 14 as nuclear number 14, but the proton number remains same. So it has how many particles? So we write down PEN. The proton will be 6. Neutral atom as electrons, same as protons, which is 6. Then 14 minus 6, this will be 8. Alright, so I draw the nucleus. Inside the nucleus, 8 neutrons and 6 protons. So the electron arrangement will be 2, 4. So the first shell will be 2 electron. Alright, the second shell will be 4 electron. This is the drawing that student should draw if they ask the drawing. Alright, so how to answer this question? Both carbon 12 and carbon 14 atoms show same chemical properties because both have same number of valence electron, which is 4. Alright, so how to differentiate? So we check the carbon 12. So I put here carbon 12, 6. The nucleus contains 6 proton and 6 neutron. So carbon 12 has 6 protons and 6 neutrons in the nucleus, whereas carbon 14 has 6 proton, 8 neutrons. So carbon 14 has 6 protons, 8 neutrons in the nucleus, and both shows different physical properties. Alright, so here carbon 12 and carbon 14 are isotope because both atoms show same number of protons but different number of neutron. If they ask us to state the function of carbon 14 to determine the age of fossil and age of ancient artifacts. Alright, so another type of essay question. So this essay question regarding atomic structure. So the conversion of matter is given, the particle are arranged closely packed. So please check the question. So the substance X are arranged closely packed but not in order, therefore this substance X in the liquid form state. And here the particle are arranged loosely. Alright, there's a space between the particles, so the particle Y will be in gas state. Alright, so name the process where liquid changing into gas. Alright, liquid changing into gas, the name of the process will be boiling. And please remember process 2. So gas changing into liquid will be condensation process. Then that can undergo sublimation from solid changing into gas. Alright, sublimation process means the particle from the physical state of solid will change into gas state. So please remember 4 substances that can undergo sublimation will be dry ice. Dry ice. Number 2 will be moth mothball or naphthalene. All right, number 3 will be crystal iodine, and the last one will be crystal ammonium. All right, ammonium chloride. These are the substance can undergo sublimation process where we can turn from the solid state to the gas state. All right, so we move on to the second question. All right, they want us to compare the electron arrangement between the arrangement of between particles X, Y in terms of following following aspect. First, they want us to determine the arrangement of the particles. So I try to do table. I put the first point, arrangement of the particle in the liquid state. Particle are arranged closely packed but not in order. In gas, particle Y are arranged loosely and further away from one another. Next one, they want the movement. Go for second aspect that they want. So the movement of the particles, the movement of particle X, they move throughout the liquid and collide one another. Particle Y, they move randomly and collide each other more rapidly. So the third aspect that they want is the forces of attraction between the particles. So in liquid, the forces of attraction will be moderate, and in gas the forces of attraction will be very weak. All right, so the energy content, the energy storage in the particles, in liquid moderate, and in gas they are vibrate very fast and move randomly, so they have high energy content. So once we need to present this one in the table form. All right, so next one, so we go for next, the mole concept and the chemical formula. So under here, to determine the relative atomic mass, RAM, RMM, and also RFM. RAM is the average mass of atom. So this is for atom. RMM is used for molecule, and RFM is used for ion. So the mass of an particle is very small or tiny and discrete. Therefore, scientists we use average mass of an atom compared with the standard atom, which is carbon-12. Carbon-12 is used as a standard atom because it's the most abundant element, exists as solid at room temperature. Many elements can combine with carbon-12. The mass spectrometer at that time already used carbon-12 as a standard atom. All right, so if let's say they ask how to write the relative atomic mass, the formula of relative atomic mass, so average mass of one atom of an element when compared with 1/12 mass of one carbon-12 atom. If let's say in the exam mass is given, mass is unit gram, is given how to find the number of mole, mass over molar mass. From here, I try to get one more formula, which is mass. How to find the mass? We take the number of mole, we times with the molar mass. So take the number of mole times with the molar mass. How to find the molar mass? How to find the molar mass? We use the method to calculate RMM, all right, or RFM. All right, so we go for next one. If let's say volume of gas is given, volume of gas is given, Cm power 2, please remember this is area. All right, Cm power 3, please remember this is volume. Let's say in the question they give volume of gas in Cm power 3 or Dm power 3. How to find the number of mole? We take the volume divide with molar volume. If let's say the m power 3, so make sure times with 1000. All right, times with 1000. So here I times with 1000. So the formula for the number of mole, if volume given is volume divide with molar volume. If in Cm power 3, please times 1000. All right, so if let's say we want to find the volume of gas in Dm power 3, we take the number of mole times with the molar volume. All right, so next one, if let's say the particles is given, the particles can be particles, how many atoms, how many ions, all right, how many molecule is asked in the question. So how to find the number of mole? We take the number of particles that asked in the question, we divide with the Avogadro constant. So the Avogadro constant is 6.02 times 10 to the power of 23 per mole. All right, so when we want to find the number of atoms, number of ions, or number of molecules, we take the number of mole, we times with Avogadro constant. And please remember one more formula. If molarity, capital M, molarity stand for the concentration of the liquid. All right, so the unit for molarity, mole Dm -3, and volume is given in Cm power 3. To find the number of moles, so we take N equals to, we take the molarity times with volume divide with 1000. So the formula mv over 1000. From here we want to find the molarity, we take the N times with 1000 divide with volume. So these are the formula that student must remember. All right, so we now look at this question under first question. We try to do first question. Okay, the mass of magnesium atom is 2 times heavier than the carbon atom. Find the relative atomic mass of magnesium atom. So we put RAM of magnesium divide with the RAM of carbon. It will be 2 times heavier. So we want to find the RAM of magnesium. So we do what? 2 times with RAM of carbon. Please remember RAM of carbon will be 12. So we take 2 times with 12. That will be the answer 24. Alright, so we try to do the question number 2. Alright, how many atoms of oxygen will have the same mass as one copper atom. So I represent the atoms of oxygen atom with Y times with RAM of oxygen atom, same as, all right, same as one atoms of copper, so RAM of copper. So I try to apply Y times with RAM of oxygen given here 16, so I put 16 times with equal as 1 times with RAM of copper is given 64, so I put 64. So we try to find the Y1 times with 64 divide with 16, so the answer will be 4 atoms of oxygen. All right, so we move on to the next question. Question number 3, find the relative molecular mass of hydrated copper 2 sulfate. Here the compound formula is given. All right, so we try to find the RMM of Cu SO4 5 H2O. So the copper is 64, sulfur is 32, plus oxygen 4 times 16. So we have oxygen 4 times 16. So we open bracket, we close bracket, hydrogen 2 times 1 plus 16, and everything we must times with 5. So when we find the answer 64 plus 32, and this one we will get 64, and everything here 18 times 5 will be 90. So the answer will be 250. All right, so we move on to the next question. A compound with the formula. The formula is given X2CO3. All right, as a relative formula mass of 138. So I put here relative formula mass 138. We need to find the relative atomic mass of X. So we have 2X. All right, then plus with RAM of carbon will be 12 plus 3 times 16. RAM of oxygen is 16 equal as 138. All right, so we put 2 times with RAM of X. All right, so plus with this 12. All right, all these 12 plus this one. So we try to find this one using calculator. So we will get 60 138. All right, so we put 2 times with RAM of X. All right, so 138 minus with 60. All right, so we will get RAM of X will be 78 divided with this 2. So the answer will be 39. All right, we move on to the next question. Check this question. Question number 1. What is the number of moles of copper 2 sulfate solution, copper 2 nitrate solution? So given to us is mass, right? Mass, and they ask question on number of mole. So we have to find the relationship between mass and number of mole. So here the mass over molar mass. To find the number of mole, we have to take the mass over molar mass. So I try to find the molar mass of copper 2 nitrate. So the copper is 64 plus with 2 open bracket nitrogen 14 plus 3 times 16. So we try to find the answer. The answer will be 188. All right, 188 gram per mole. So we try to take the mass. Mass is given 56.4 divide with 188. So the answer will be 0.3 mole. All right, our next one, we try to check the next question number 3. Which of the following contains 6.02 times 10 to the power of 23 atoms? So this is 6.02 times 10 to the power of 23 refers to the 1 mole, and they want the atom. Nitrogen N2 exists as molecule, so A cannot. Chlorine Cl2 exists as a molecule, cannot, even though 1 mole. And check ammonia, formula of ammonia NH3 exists as molecule, also cannot. Neon, 1 capital 1 small, exists as atom, and it has 1 mole, so the answer will be C. Alright, we move on to the next question. Question number 2. Okay, how many molecules are there in 150 cm power 3? When they give 150 power 3, please remember this is volume. Cm power 3 is volume, and we need to find the number of moles. So we take the volume divide with molar volume, and please check if volume in cm power 3, please times 1000 for molar volume. All right, so this is the first step the student must remember, and they want the how many molecules. That means they want the particles. Okay, if we want to find the particles, we have to take number of mole times with Avogadro constant. So these are the two formulas that student must use to tackle this question. So I start with point number 1. We have to find volume, number of mole, volume divide with molar volume, and this molar volume, when the volume given in cm power 3, don't forget to times with 1000. All right, so I try to do the answer 150 times with 24 times with 1000, so the answer will be 0.00625 unit will be mole. All right, so I'll do the second step here. The second step, they want the number of carbon dioxide molecules, so I put here number of carbon dioxide molecules. So how to find the number of carbon dioxide molecule? We take the number of mole times with Avogadro constant. So we use this formula. All right, so the number of mole is given 0.00625 times with the Avogadro constant already given here, 6.02 times 10 to the power of 23. So the answer will be 3.76 times 10 to the power of 21 molecules of carbon dioxide. All right, we try to check question number 4. All right, question number 4. All right, so the which of the following contains same number of molecules in 8.8 gram of carbon dioxide? So we try to find the carbon dioxide RMM of carbon dioxide, RMM or molar mass of carbon dioxide. So we have 12 plus 2 times 16, that will be 44. So we take 8.8 molar mass over molar mass 44, so we will get the answer 0.2 mole. And we try to check which substance contains 0.2 molecule. So this is sulfur dioxide exists as molecule, oxygen exists as molecule, iodine exists as molecule, water molecule. All right, so I'll try to check for the sulfur dioxide. So we try to find the number of mole of sulfur dioxide, 9.6. Sulfur dioxide, sulfur 32 plus 2 times 16. So the answer will be 0.15 mole. So it not the answer. We try to check for the oxygen number of mole of oxygen. So we take 3.2 divide with 2 times 16, so the answer will be 0.1. So this one also not same as the carbon dioxide. All right, we try to check for the iodine, the number of mole of iodine. So the mass is given 25.4 and the RMM or molar mass 2 times 1 to 7. So the answer number of mole we will get 0.1 mole. Alright, so this is not the answer. We go for number of mole of water molecule. The mass is given 3.6. Alright, so here the molar mass 2 times 1 plus 16. Alright, so we will get the answer 0.2 mole. Alright, 0.2 mole. 0.2 mole same as the number of mole of 8.8 grams. So the answer will be A. Alright, we move on to the next question. Alright, look at this question. We try to do this question. What is the number of nitrogen atoms? Nitrogen atoms in NH4NO3. So please remember NH4NO. This is molecule. This molecule contains 2 nitrogen atoms. Alright, 2 nitrogen atoms. And here we are given mass. So first step, find the number of mole. How to find the number of mole? So we take mass over molar mass of the molecule given. The mass of given here is 40.0, divide with the molar mass nitrogen 14. We have nitrogen 14 plus 4 times 1, the hydrogen 4 plus 1 more 14 plus 16. So this is the number of mole. We try to find the number of mole. Alright, 40.0 divide with 48. So we will get the answer 0.83 mole. Alright, so the second step, we need to find the number of nitrogen atoms in this compound. So we go for number of nitrogen atoms. Right, nitrogen atoms. So in this compound NH4NO3, we have 2 nitrogen atoms. So I put 2 nitrogen atoms times with the number of mole times with the Avogadro constant. So 2 times with the number of mole 0.83 times with the Avogadro constant, which is 6.02 times 10 to the power of 23. So the answer will be 9.9 times 10 to the power of 23 atoms of nitrogen. Alright, so this is the answer. So we go for last question. Alright, check the question. Alright, so we read the question. 3.2 gram of 2 gram of gas X is occupied 1120 cm power 3 of volume at standard temperature and pressure. What is the relative molecular mass? They want us to find RMM. So the first formula that we have to use this point, and we already have STP is given. So we try to find the number of mole of gas S, then only we try to use this formula, N equals as mass over molar mass. Alright, the molar mass refers to the RMM. So we try to find number of mole, N equals as volume divide with molar volume. Please check the unit given here, cm power 3. So here we times with 1000. So the volume 1120 divide with 222.4 times with 1000. So the answer that we will get is 0.05 mole. Alright, second step, we try to do the second step. We take this formula, mass over molar mass. So the smaller mass refers to the RMM. So we change this one into RMM. From here, we want to find the RMM. So how to find the RMM? We take the mass, divide with N. Bring this one down, bring this one up. Alright, so the mass given here is 3.2 gram and the number of mole that we already obtained is 0.05. So the answer will be 64. So this is the answer. So we move on to the next part. We try to write down the formula of all the cation, anion, and we try to check how to write the chemical formula. Alright, so I'll start with the formula of cation. So please remember cation stand for positively charged ion, and the formula, please remember potassium K positive. Alright, K positive, sodium ion Na positive, calcium ion Ca2 positive. Please don't write like this wrong. Alright, so Ca2 positive, magnesium ion. Please memorize all these ion. Mg2 positive, aluminium ion Al3 positive, zinc ion Zn2 positive, iron 2 is Fe2 positive, iron 3 is Fe3 positive, tin or sternum ion Sn2 positive, lead 2 ion Pb2 positive. Alright, so Pb2 positive, and hydrogen ion H positive, copper 2 ion Cu2 positive, and we have copper 1 ion Cu positive, silver ion Ag positive, ammonium ion NH4 positive. So ammonium ion will be NH4 at the bottom and positive. Alright, so these are the cation that student must remember. We move on to the anion. Anion stand for the negatively charged ion, and the formula of the famous anion will be fluoride ion F negative, sulfate ion SO4 2 negative, nitrate ion NO3 negative, chloride ion will be Cl negative, carbonate ion CO3 2 negative, bromide ion will be Br negative, iodide ion I negative, oxide ion O2 negative, hydroxide ion OH negative, thiosulfate ion S2O3 2 negative. Alright, then we have a manganate 7 ion MnO4 negative, and this is purple color ion, please remember, and dichromate 6 ion Cr2O7 2 negative, and this is orange color ion, so please remember the O stand for orange color. Alright, so these are the famous anion that student must remember. We try to do the formula. Please remember the formula of the chlorine, don't write like this wrong. For chlorine exists as diatomic molecule, so we have to put Cl2. So the formula of magnesium ion Mg2 positive, Cl negative, so we write like MgCl, take the 2, put at the bottom of the Cl. So we try to write down the formula of zinc nitrate. Alright, so zinc ion Zn2 positive, nitrate ion NO3 negative. So I do ZnNO3. So I take the value 2 at the, we put at the bottom. So when we have like this, alright, so please open bracket and close bracket and put 2 here. The 2 must go to all sodium atom, nitrate atom, and oxide atom. Alright, so please remember. Then copper 2 sulfate, Cu2 positive, SO4 2 negative. So when the charge number is same, cancel, we do CuSO4. Alright, so copper 2 oxide, Cu2 positive, and oxide O2 negative. When charge value same, so we cancel, so we put CuO. Alright, so we check the next one, aluminium oxide, aluminium ion A3 positive, oxide ion O2 negative. So the formula will be ALO. Take the 3, put at the oxygen, take the 2, put at the aluminium. Alright, so this is the formula that for the aluminium oxide, and I try to do for the aluminium ammonium sulfate. The formula of ammonium ion is NH4 positive, sulfate ion SO4 2 negative. So we put here NH4. Alright, so I put here SO4. Take the 2, put at here. So when we get like this, open bracket and close bracket. Close bracket. Alright, so the 1 no need to put here. So this is the formula, open bracket and close bracket. So please remember. So next one, write down the formula of ions present in magnesium oxide. So we try to answer Mg2 positive and O2 negative. O2 negative, potassium ion and chloride ion, K positive and chloride ion. The question, write down the formula of the compound form. So what is the formula of compound form? So here Mg2 positive and we have oxide ion, so MgO. Alright, so next one, we try to do the potassium chloride. Alright, potassium chloride, K positive and Cl negative. So when charge value same, so we just put KCl. Iron 2 sulfate, Fe2. Alright, SO4 2 negative. So we try to do when the charge value 2 negative same, so we cancel, we put Fe SO4. Alright, sodium carbonate, sodium ion Na positive, carbonate ion CO3 2 negative. So I put here NaCO3. So I take the value 2, put in money at the bottom of sodium. Alright, so nitric acid, please remember HNO3. So the nitric acid will be HNO3. Sulfuric acid, please remember H2SO4. Silver nitrate Ag positive, the nitrate ion NO3 negative. So I put here silver nitrate. When the charge value same, so no need to add anything. Alright, so here ammonium chloride, ammonium ion, NH positive, Cl negative. So when the charge value is same, charge number same, so we just do NH4Cl. So these are the formula that student must remember. Please try to do more practice. Alright, so I move on to the next one. Next one, important chemical equation that student must remember. The chemical equation represent the chemical reaction by using the formula for the participating substance. So we have here we have reactant, the substance that react. Alright, this symbol stand for react. Alright, and this symbol stand for produce. Please remember. Alright, and the product will be C and D. Alright, so when we try to check the formula of magnesium Mg, so first question we try to check the formula Mg react with oxygen O2. We try to find the answer magnesium react with oxygen. So I'll try to get the ion Mg2 positive and oxide ion. So during chemical reaction both join, so I will get MgO cancel. Alright, so then we need to balance the equation. Make sure the number of atoms present on the left hand side and right hand side same. So I balance with oxygen 2, so I put 2 oxygen, magnesium 2. So we try to check with another one, zinc react with oxygen. So zinc will form Zn2 positive, oxide O2 negative. When joined together, so we will get zinc oxide. When charge value same, cancel. Alright, how to balance this equation? Make sure the number of atoms present on the left hand side and right hand side is balanced. So this is burning process. Balance the oxygen first, oxygen 2. So I put 2. I make sure the oxygen balance 2. So zinc 2. So I put zinc 2. So this is the one we have to do. Alright, next one. If let's say, please remember all group 1 metal. Group 1 metal we call Lina. So they will form ion with positive 1. Alright, so ion with positive 1. If let's say any element from group 1, please remember it will form positive 1 ion. So we check this one. Alright, we try to check group 1 X may react with water. Group 1 metal X is a group 1 metal react with water. So how to do the equation? So please remember this one. So group 1 metal react with water. Alright, so what product we will get? So group 1 metal, take the formula of the ion, X positive, water, we break like this, hydrogen ion and hydroxide ion. During chemical reaction join, so we will get X. When the charge value same, so we just put XHO. When hydrogen ion single, so we do like this, hydrogen, we make sure get hydrogen gas. So we put the hydrogen gas here. Alright, so how to do the balance the equation? So in this case, we balance hydrogen 2, here hydrogen I have 3. So the odd number we make it even, hydrogen 2 plus 2 4. So hydrogen 2 times 2 4. Alright, so next we balance X2. So the equation is balanced. Oxygen 2. So the equation is balanced. We try to do with the same atom from group 1, sodium react with water. So how to balance there? Get the formula of sodium ion. So I bring down the hydrogen ion. I bring down the hydroxide ion. During chemical reaction when join, so the charge value same, so we will get sodium hydroxide. When we see the hydrogen ion single, just put hydrogen gas. Alright, so how to balance the equation? In this case, try to balance the hydrogen 2, here hydrogen 3. The 3 we make it 4, 2 4. So here I put 2 times 2 4. Alright, so next we balance oxygen balance, sodium 2. So that's how we balance the equation. Alright, so we try to check another question. If let's say sodium react with oxygen. Alright, so take out the sodium ion Na positive, take out the oxide ion O2 negative. So we write the formula NaO, we take the 2, we bring to the sodium. Alright, bring to the sodium. So how to balance the equation? This is burning process. Please balance the oxygen. Oxygen 2. Alright, so I make sure oxygen here 2. Now hydrogen, sodium 4. So I put sodium 4. Alright, so all these please try to read and try to remember. Alright, so and please remember this is neutralization reaction. So an acid present react with metal carbonate, we will get salt plus carbon dioxide plus water. So how to do the equation is given here. Alright, so and please remember when we have a metal carbonate, it will decompose to give you metal oxide and carbon dioxide. Please remember this word form equation. Alright, so and we try to do the combustion process. We take any organic compound. Alright, any organic compound burn in the presence of oxygen, we will get the product will be carbon dioxide and water. Please remember organic compound is made up of carbon and hydrogen only, or carbon, hydrogen, and oxygen only. So these are the all carbon organic compounds. So I'll take the first one. If let's say ethane C2H will be 6 is burned in the presence of oxygen. So please check this compound is organic compound. Why? It's made up of carbon and hydrogen only. So the product will be carbon dioxide and water. Alright, how to balance the equation? I try to balance the carbon, carbon 2, carbon 2. Next, I balance hydrogen 6, 3 times 2, 6. Alright, so next I calculate the total number of oxygen present on the right hand side. So here 4, so here we have 3, total 7. So we try to put the fraction 7 over 2. Alright, so when we put 7 over 2, O2 cancel, that will be 7O. Alright, so we already get the fraction. We try to remove the fraction by times all this equation by 2. So we multiply all the substance present in the equation by 2. So I will get 2C2H6 plus we will get times 2. So we will get 7 over 2. Cancel. Alright, so we have 4 carbon dioxide plus we times here 6 water molecule. So we try to check carbon 4. So here carbon will be 4. We try to check hydrogen 12. So hydrogen will be 12. We try to check oxygen 14. So here we have 8. Alright, so and here we have 6, so that will be 14. Alright, so we try to do another example. If let's say ethanol C2H5OH undergo combustion process, the product will be carbon dioxide and water. Why? Because it's made up of carbon, hydrogen, oxygen. So this is organic compound, carbon dioxide plus water. So first we balance the carbon 2. So I balance carbon 2. Second, we balance the hydrogen 5 plus 1 6. So 3 times 2 6. Alright, so next we try to calculate the number of oxygen present on the right hand side. So this here 4 plus here I got 3, total 7. And don't forget to include this one, oxygen 1. Alright, plus how much? We will get 7. 1 plus 6 will be 7. So here I need 3. So the total oxygen here, so from here 1, from here we got 6, so total will be 6. So this is the answer that student must write. Alright, try to practice and do more question on this part. Alright, so all the important equation is given, so please study. Alright, please do more revision. Alright, so we move on and interpreting the chemical equation qualitatively and quantitatively. This is very important for the first test. So please remember qualitative aspect. We have to state the reactant A, okay, and the name of the product, and we have to state their physical condition of the whether they exist in solid form, liquid form, alright, or gas. Alright, so next one, quantitative aspect. We have to state the number of moles of reactant and the product involved in the chemical reaction, coefficient involved, balance equation. So after we balance the equation, so we have to check the formula. In front of the formula we have to get the number of mole. For example, we try to do this one. When magnesium react with oxygen, we will get magnesium oxide. Please remember magnesium exists as solid, oxygen exists as gas, and magnesium oxide will be solid. So the first point, qualitative aspect. The reactant used is magnesium and oxygen. The product form is magnesium oxide. The magnesium is a solid and the oxygen is a gas, and the magnesium oxide is solid. This will be the qualitative aspect. Alright, so we go for quantitative aspect. So we check the equation. We have to balance the equation. Here 2 mole of magnesium, so this word react. The plus stand for react with 1 mole of oxygen. Then this one produce 2 mole of magnesium oxide. We try to do another example. Look at here, copper 2 oxide. Alright, copper 2 oxide. Please remember copper 2 oxide react with hydrogen. Please remember hydrogen love to take oxygen to form water molecule. So that means here copper, so hydrogen will take the oxygen, so we will get a water molecule. So this is the product that we will get. So in this section we check the equation is balanced. So how to interpret describe the chemical equation qualitatively and quantitatively. So I'll go for qualitative aspect. The reactant used is copper 2 oxide, and the one more will be hydrogen gas, and the product form is copper and water molecule. Copper 2 oxide, please remember, exists in the form of solid. Alright, hydrogen exists in the form of gas, copper will be solid, and water will be liquid. Alright, so quantitative aspect. 1 mole of copper 2 oxide, 1 mole of copper 2 oxide react with 1 mole of hydrogen gas and produce 1 mole of copper and 1 mole of water molecule. Alright, if let's say A react decomposes to give B plus C. For this, how to describe the equation qualitatively and quantitatively, we try to check calcium carbonate decomposes to produce calcium oxide and carbon dioxide. So in this case, carbon dioxide is a gas. Carbon dioxide is a gas, calcium oxide is solid, and calcium carbonate is solid, and calcium oxide also solid. The reactant used is calcium carbonate, and the product form is calcium oxide and carbon dioxide. Calcium carbonate is a solid, and calcium oxide also is a solid, and carbon dioxide is a gas. So how to describe quantitatively? 1 mole of calcium carbonate decomposes to produce 1 mole of calcium oxide and 1 mole of carbon dioxide gas is released. So please use these terms, decomposes. Or then let's move on to the next question. So look at this question. A carbon compound with the empirical formula CH2 is given and the RMM is given. So how to find the molecular formula? Alright, so how to find the molecular formula? So we write the empirical formula given in the question. So we open bracket, close bracket, we put n, so we take the RMM, we try to apply in the formula. So CH2 we empirical formula and we put n, then we take the RMM value which is 70, so we put here. Alright, so the carbon will be 12. Alright, so plus with 2 times 1, the RAM of hydrogen is 1, so we put n is 70. So 14n will be 70, so we try to find the n value which 70 divided with 14, which will be 5. Then we apply in this formula, we try to apply here, right? CH2, right? The n value is 5, so we times here, so the molecular formula will be C2H will be 2 times 5 will be 10. So that's how we try to find the molecular formula. Alright, so next we try to do the calculate the percentage of nitrogen that present in the fertilizer. So try to find the percentage by mass of nitrogen in ammonium sulfate. So how to find? So we try to take the mass of nitrogen in ammonium sulfate. So we have 2 nitrogen atom here. Alright, so in this ammonium sulfate we have 2 nitrogen atoms, so we times with 2 times 14, so we find the RMM of ammonium sulfate and times with 100 percentage, so we will get 21.21 percentage. So we try to do another similar question. We try to find the percentage of nitrogen per mass of ammonium nitrate, where the RAM of nitrogen is 14, hydrogen is 1, and oxygen is 16 is given. Right, so how to find here? So we check here, we got 2 nitrogen atoms, so I put here 2 times RAM of nitrogen divide with RMM of all these compounds. So we put here NH4 NO3 ammonium nitrate times with 100 percentage. So 2 times with RAM of nitrogen will be 14 divide with RMM of this molecule, which will be 14, 4 times with 1 plus 1 more 14, 3 times with 16, and we times with 100 percentage. Alright, so here we will get 28 divide with 80 times with 100 percentage, and the answer will be 35.0 percentage of nitrogen present in ammonium nitrate. So please go through all these questions and try to do. Alright, so we move on to the next question. Alright, so this is the symbol given W, alright, as proton number. So the proton number is 3, and the nuclear number is 7. And when we take the proton number, we do the electron arrangement 2.1. Alright, so always remember when valence electron 1, 2, 3. Alright, so the element will form cation. How they form the cation? By donating its valence electron. Alright, so W will form cation, it will donate the 1 electron, so we put 1 here, so it will form the formula of ion W positive. Alright, so when W react with oxygen, the formula of oxygen O2. Alright, so oxide of W is formed. We try to write down the equation. W react with oxygen. So what formula we will get? Take out the W ion W positive and oxide ion O2 negative. During chemical reaction, they will join. So we will get WO. Take the 2, we put here. Alright, so we put here at the W. Alright, so how to balance the equation? So this is burning process. So we balance the oxygen 2, here oxygen 1, so I times 2. Now oxygen 2. W 2 times 2, 4. So here is the 4. Right, so next question. So we try to do the next question. Right, calculate the mass of oxide of W is formed. Alright, so this is known as stoichiometric calculation. So what information given to us is 0.05 mole of W. Alright, so we need to find the ratio mole of W and also W to O. Alright, so how to find here? So the answer 0.05 mole is given of W is given here. So we check this value, we divide with 4. So we will get the answer will be 0.0125. Alright, 125. So how to find the ratio mole? So I put here 4 mole of W react with 2 mole of W2O. So we take this value, we times here 0.0125. So when we times with 0.0125, we will get 0.05. Here 2 times with 0.0125. So we will get the ratio of 0.025 mole. Alright, so that means we take the 0.05 mole of W. We take the 0.05 mole of W, put here, it will react and produce 0.025 mole of W2O. So we put here 0.025 mole of W2O. Alright, so next step, we try to find the mass of W2O. So we use this formula, from this formula, mass over molar mass. So we try to find the mass of W2O. We rearrange the formula, we take the number of mole of W2O times with molar mass. So the number of mole given here 0.025 times with the molar mass of W2O. So the RAM of W is given 7 and oxygen is given 16. Alright, so we have 2 times 7 plus with oxygen 16. So we close the bracket, we try to find the answer. So the answer will be 0.75. So unit for mass will be gram. Alright, this is known as stoichiometric calculation. Please do more question on this part. We move on to the next question. Try to discuss another question. So in this table shows the two chemical formula. Ammonium sulfate, the formula is given. Urea, the formula is given. So we try to read the questions, calculate the percentage by mass of nitrogen in each compound and state which fertilizer is best fertilizer and explain your answer. Then the RAM of all the elements that present in the compound is given. Alright, so we try to check the ammonium sulfate. The formula of the ammonium sulfate, NH4 bracket 2SO4. We try to find the RMM of ammonium sulfate, so the answer is 120. And we try to find the RMM of urea. Urea is CONH2 bracket 2. Alright, so once we find the RMM, we already get the 60. So how to find the percentage of nitrogen by mass in ammonium sulfate? Nitrogen, here we have 2 nitrogen. So we take the 2 times with RAM of nitrogen, divide with RMM of this molecule, times with 100 percentage, we already get 21.1 percentage. And we do the same thing for the urea. Urea also contains 2 nitrogen atoms, so 2 times with 14, divide with RMM of urea, which is 60. So we put 60 times with 100 percentage, we will get 46.67 percentage. So the percentage of urea, the percentage of nitrogen by mass of urea is higher. So this one is higher, this one is lower. Alright, so the urea has higher percentage of nitrogen per molecule compared than in ammonium sulfate. Therefore, urea is better fertilizer compared to ammonium sulfate. Alright, so we move on to the next question. This question is known as stoichiometric calculation. Under stoichiometric calculation, we have to do the equation, then we have to find the number of mole via the value given in the question, and we have to find the ratio, and we have to find the answer requirement of the question asked in the question. Alright, so we move on to the question. So sulfuric acid, please remember the formula, H2SO4 reacted with sodium carbonate. Sodium carbonate Na positive, CO3 2 negative. So the formula will be NaCO3. We take the 2, we put here. Alright, please remember sodium carbonate is known as metal carbonate. Alright, so metal carbonate. And how to do the equation? I'll do here sulfuric acid. Sulfuric acid react with sodium carbonate. So we will get what product? So we take out the hydrogen ion, we take out the sulfate ion, and we take out the sodium ion, and we take out the carbonate ion. During chemical reaction, sodium combined with sulfate ion, always put the cation ion in front, and ion. So sodium sulfate, we take the 2, we put in front of the sodium. So we already get another product, one product. So when hydrogen ion combined with carbonate ion, it will produce carbonic acid, and this substance is unstable. It will rearrange to produce carbon dioxide and water. Alright, so here we will get carbon dioxide and water. Alright, we try to balance the equation. And please remember, when acid react with metal carbonate, we will get salt plus carbon dioxide and water. Alright, how to balance the equation? We check sodium 2, we check carbon 1, we check sulfur 1, hydrogen 4 plus 2, 6 plus 1, 7. Here oxygen will be 6 plus 3 plus 4, 7. So the equation is balanced. Alright, so next we check the value given in the question. We convert the value into number of mole. So the the value given in the question, so we have two value. This Cm power 3 stand for volume, and 1.0 mole Dm negative 3 stand for molarity or concentration. So when we have mv, we try to convert into number of mole, and this mv, volume and concentration, belongs to sulfuric acid. So the first step, we convert the volume and molarity given into number of mole. Number of moles of sulfuric acid. So the number of mole of sulfuric acid, we use formula mv over 1000. All right, so we apply the number of mole given is 1.0 and volume is 100. So 1.0 volume is 100 divide with 1000. So we will get answer 0.1 mole. All right, so sulfuric acid 0.1 mole. And please check the requirement of the question. They want write the chemical equation. What is the volume of carbon dioxide? So I circle the sulfuric acid. So here is 1 mole. All right, so react and produce 1 mole of carbon dioxide. So we do the ratio. How to find the ratio? 1 mole from the equation. 1 mole of sulfuric acid will react and produce 1 mole of carbon dioxide. We take this mole, 0.1 mole. We find the ratio of carbon dioxide. If here 1 mole and 1 mole, take this mole, just put yours. All right, so take this mole, just put your 0.1 mole of carbon dioxide. All right, for this we will get 1 mark. And third point, they want the volume of carbon dioxide. So we put your volume of carbon dioxide. How to find the volume of carbon dioxide? We use this formula from the formula of volume divide with molar volume. So how to find the volume? We take the number of mole times with molar volume. The number of mole given here is 0.1 times with the molar volume given in the question. We check the question STP, which is 22.4. So I times with 22.4. So we will get 2.24. The unit will be dm power 3. So I'll take the dm power 3. For this type of question, student will get 3 marks or 2 marks. Alright, so please remember the stoichiometric calculation and do more question on this part. Alright, we try to do few example of stoichiometric calculation. So in order to do the stoichiometric calculation, first we have to write the chemical equation, convert the unit given in the question into number of mole. Based on the equation, we compare and find the ratio mole. So we must use based on the equation. And next step, the final step, calculate the answer proportionally, then convert the answer to the unit required. So we check the first question, we try to do the first question. So in this first question, decomposition of lead 2 nitrate. So the formula of lead 2 nitrate, Pb2 positive and nitrate ion NO3 negative. Alright, so we check the requirement of the question. They want us to find the mass of lead 2 nitrate, and given unit is 3.6 dm power 3 of oxygen gas. So this is known as volume. This is known as volume of gas. So first we take the unit, we convert into number of moles. So the first step will be number of moles of oxygen gas. Alright, so we will use the formula volume divide with molar volume, and we no need to times with 1000. Why? Because the unit given here is dm power 3. All right, so we take the 3.6 divide with 24, the RTP already given, so the answer we will get is 0.15 mole. Alright, so next we have to find the ratio between oxygen and also lead 2 nitrate, and we check the information that we have is oxygen. From the equation we have the information about oxygen is 1 mole is produced. Alright, so we take the 0.15 divide with the 1 mole that produced from the equation, so we will get 0.15. Alright, so then we check the equation, 2 mole of lead 2 nitrate produce 1 mole of oxygen gas. How to find the ratio mole? So we take the 0.15, we times here 15, so we will get 0.15 mole of oxygen. Here we take the 2 times with 0.15, we will get the answer 0.3. So once we already get this, then we try to do the ratio mole. How to do the ratio mole? Second step I'll do here. Alright, so 1 mole of oxygen is produced from 2 mole of lead 2 nitrate, and we take the 0.15 mole of oxygen is produced from, we take this ratio 0.3 mole of lead 2 nitrate. So we already find the number of mole of lead 2 nitrate, and final step we need to find the mass. Alright, mass of lead 2 nitrate. So how to find the mass of lead 2 nitrate? So we want to find the mass of lead 2 nitrate. So we use the formula number of mole times with molar mass of lead 2 nitrate. So the number of mole we already find here 0.3. So we open bracket, close the bracket, the RAM of lead is given 207. So we take the 207, we times here. Alright, so plus with open bracket nitrogen 14. Alright, oxygen plus oxygen 3 times 16, close the bracket, and we all think we must times 2. Alright, so we will get 0.3 times with 0.3 times with this one. All these things, when we calculate, we will get 331. So the mass of the lead 2 nitrate produced used is 99.3 gram. Alright, so this is the first step that student must write, and the second step will be here, and the third step is here. So please do more question. We try to do another example of question. The combustion of propanol will produce carbon dioxide and water. So what is the volume of carbon dioxide produced when 48 cm power 3 of propane is burned completely? So the first step that we should do, write the equation. C3H8 is an organic compound when burned in the presence of oxygen. So we will get carbon dioxide and water. The second step, we need to balance the equation. So I check carbon 3, so I balance carbon 3. Then I check hydrogen 8, so I put here 4 times 2, 8, hydrogen 8. Then I calculate the total oxygen present on the left hand side. Here got 6. Alright, so oxygen here got 6, then here got 4, so the total will be 10. So how to get 10? 10 times 5 times 2, 10. So we already balanced the equation. So the second step that we need to do, we convert the value of 48 cm power 3 of propane into number of moles. So this is volume. So please remember, this is volume. How to convert and present in cm power 3, how to convert into number of moles. So we put here number of moles. Number of moles of C3H8. So we will use the formula of volume. Volume divide with molar volume. Right, molar volume must times with 1000 because the unit is cm power 3. So here the volume 48 times with 24 times with 1000. So the answer that we will get is 0.002 mole. Alright, so next step, we need to find the ratio. So we try to read the question. So they want us to find the volume of carbon dioxide. They want us to find the volume of carbon dioxide and the ratio. So we need to find the ratio between propane and also the carbon dioxide. So what we do, we take this mole, 0.0 propane. So here we have 1 mole. Alright, so please check from the equation. So we have 1 mole. So what I do, I take C3H8 from the answer given. So we take 0.002 divide with the 1. So we will get 0.002 mole. Alright, so we try to find the ratio. How to find the ratio? So we take C3H8 is 1 mole, give us 3 mole of carbon dioxide. So we take this one times your 1 times with 0.002, so we will get 0.002 mole. Alright, so here we times with 3. 3 times with 0.002 mole, so we will get the answer 0.006 mole. Alright, so now we try to do the ratio. Second step will be here. Alright, from the equation, 1 mole of C3H8 produce 3 mole of carbon dioxide. 3 mole of carbon dioxide. Alright, so then we check this one. So from the 0.002 mole of C3H8 will produce, we take this mole and mole, we put here 0.006 mole of carbon dioxide. And we go for final step. How to do the final step? We try to find the volume of carbon dioxide. How to find the volume of carbon dioxide? From this formula, volume divide with molar volume. We try to find the volume of carbon dioxide, number of mole times with molar volume, which is given in the question. So number of mole, we take this mole 0.006 times with the molar volume given in the question is 24. So we try to put times with 24. So the answer will be 0.144. A unit will be dm power 3. Right, the unit will be dm power 3. Alright, so this is the answer that student must remember. So all the step I go through again. The first, number of mole of propane, we have to find the number of mole of propane. So we take the 0.2, so we take the 0.002, we divide with the number of mole of propane from the equation, which is 1. So we get this. How to find the ratio? This is 1 times with 0.002, so we will get 0.02. 3 times with 0.002, we will get 0.06. And convert this into word form. So we write like this: 1 mole of propane produce 3 mole of carbon dioxide. 0.002 mole of propane will produce 0.006 mole of carbon dioxide. So the volume of carbon dioxide, we find number of mole times with molar volume. The number of mole, we take the number of mole of this, we times with the molar volume, which is 24. So we already get 0.144 dm power 3. So that's how we do the stoichiometric calculation. Then we move on to the next question: how to determine the empirical formula. If we want to determine empirical formula, please do a table list of element. Make sure the element that we put in the form of atom, and we try to find the mass of the element given in the question, convert them into number of mole. We can use mass over molar mass. The formula, we can use mass over molar mass, and we need to find the ratio. We try to do two questions here. So the first question, 1.6 gram of iron. So I put iron symbol Fe, is bonded with 0.72 gram of oxygen. So please don't put O2, please try to put oxygen oxide atom. All right, so we try to find out how to find the empirical formula. So first step, I do the table, I find the mass, I put in the table. So this is 1.69 gram. All right, so next one, the mass of oxygen is 0.72 gram. All right, so we try to find the number of moles. All right, so the unit I put here mol. So how to find the number of mole? We will use the formula of mass over molar mass. So how to find 1.69? The RAM of iron is given 56. So we divide with 56. The answer will be 0.03. All right, mole. All right, so we already put the unit here. So then we try to do for oxygen 0.72 divide with 16. So we will get 0.045 mole. All right, so we will get answer will be 0.045 mole. So here 3 decimal points. So I make it 0.030. Alright, next step, we try to find the ratio. How to find the ratio? We compare these two values. We divide with the smaller value 0.030. We divide with 0.030. So we will get 1. So here I take 0.045 divide with 0.030. So I will get the answer 1.5. If we get 1.5, please time the ratio times with 2. Here also we times with 2. So the value that we will get here 2, here 3. So the ratio of iron to oxide is 2 to 3. So the formula, so we try to put the empirical formula. The empirical formula will be iron to oxide 3. So that's how we do the question. So we try to do the next question. To read the second question, 42 gram of R. So I put the R symbol, element is here. So I put the R symbol is here. React with the element T. So I put here. Alright, 16 gram of element T is react to produce compound with the formula R3 and T4. Alright, so we take the first thing in the table. So I write down the mass, so gram. So the mass of R will be 42 gram and the mass of T will be 16 gram. Alright, so we try to find the number of moles. Alright, the number of moles, the unit will be mole. So I take 42. We try to check the RAM given or not. So here RAMT is only given. So R is not given. So I represent with X. So this one 16 divide by 16. So we leave it like that. And the empirical formula. So find the ratio. Second step, we find the ratio. Check the formula given. The formula given R3. Alright, T4. So we take the 3, we put here, we take the 4, we put here. So we try to solve this one as a ratio. So 42 divide with X equals to 16 divide with 16 equals to 3 to 4. Alright, so we try to find 42 divide with X. So 16 divide with 16. So we will get 3 over 4. And we try to settle this one. So 42 X. So we times with 16 divide with 16. This one we bring down, bring up. Alright, so we try to find the ratio value of X. So 3 over 4. Alright, so next one we try to find the 42 X. So this one will be cancel will be 1. Alright, and we will get 3 over 4. Alright, so then we try to bring this here and this one here. So 3X, alright, times with 3 times with 42. Alright, so we will get 3X equal as 168. Alright, so then we try to find the value of X. X will be 168 divided with 3, which is 56. So then we can conclude the RAM of R will be 56. Alright, try to do more question on this part. Alright, we move on to the next question. Alright, we move on to the next question, how to find the empirical formula. I already discussed earlier, so please check the video again. So we try to go for the experiment to determine the empirical formula of reactive metal. So please remember reactive metal like magnesium and zinc. How to determine the empirical formula by eating. Alright, eating with oxygen. By eating the magnesium with oxygen. Alright, so in this reaction, so we will take magnesium reacted with oxygen. So we will get MgO, magnesium oxide. How to balance the equation? We take the oxygen, so we balance the oxygen. Magnesium will be 2, so we put 2. I try to do the equation with zinc. Zinc react with oxygen, so we will get zinc oxide. Alright, how to balance the oxygen equation? Balance the oxygen 2. So I balance the oxygen 2. Then I try to balance the zinc 2, zinc 2. So this is the equation that student must remember. And we try to do the equation is here. Explain why the magnesium coil need to be cleaned with sandpaper to remove the oxide layer from on the magnesium surface. Why the lid must open occasionally or every interval of time so that the amount of oxygen will finish where the oxygen will react with magnesium. So we open the lid occasionally to allow oxygen from the air to enter inside the crucible for the complete combustion of magnesium. All right, so how do we ensure all the magnesium is reacted completely? So we repeat three process, HWC process. We repeat the process of heating, cooling and weighing, heating, cooling and weighing until a constant mass of magnesium oxide is obtained. So we try to, after that the result will be given, we try to find the mass of magnesium, mass of oxygen, and we try to do the calculation. So how to find the mass of magnesium? We cut the crucible, we cut the crucible, we cut the lid, we cut the lid. So the one left is mass of magnesium. We take the 26.4 minus with 24.0, we will get 2.4. So the unit already put here. All right, how to find the mass of oxides? How to find the mass of oxide? So I cut the crucible, I cut the crucible, I cut the lid, I cut the lid. So magnesium, magnesium. So we have the mass of oxide. So how to find the mass of oxide? We take 28. All right, 28 minus with 26.4, we will get 1.6. Then second step, we find the number of mole mass over molar mass. We already get 0.1. So here mass over molar mass of oxygen atom RAM is given. So 16, so we will get 0.1. And we try to find the ratio, we will get 1:1. Therefore, the empirical formula is MgO. All right, we try to do this question. All right, what is mean by empirical formula? Please remember, empirical formula is known as chemical formula. Formula that shows simplest, all right, simplest ratio of all number of atoms of, must put this word, each elements that present, right, present in a compound. So this is the definition that student must understand, must learn. So while carrying out why the crucible need to be opened occasionally once in a while, to allow the oxygen from the air to enter inside the crucible for the complete, all right, complete combustion of magnesium. Right, so this is the answer that student need to write. How do we determine the reaction of magnesium with oxygen has been completed? So please remember, we repeat the process of HCW. So we put here, repeat the process of heating, cooling and weighing until a constant, right, until a constant mass of magnesium oxide is obtained. Right, so this is the answer. All right, so we move on to the next question. So look at the question. So here the mass of crucible is given, lid is given. All right, we try to find the find the mass of magnesium. So how to find the mass of magnesium? We cancel the crucible, we cancel the lid, finally we will get the mass of magnesium. So 256.29 minus with 250.05, so we will get the answer 6.24 gram. All right, so we try to find the mass of oxide atom. We cancel the crucible, lid cancel, magnesium cancel, we will get the mass of oxide. So that means 260.45 minus with 256.29, so we will get the mass of, I get 4.16 gram. All right, so next step, we need to find the number of moles of the table here. So we try to do the table like this. All right, so here I put the magnesium atom here, oxide atom. So the mass already found. The mass is gram, which is 6.24, and this is 4.16. We try to find the number of moles. So I put here unit mole is here. Alright, 6.24 divide with the RAM of magnesium, which is 24, is so will be 0.26. Alright, so I do 4.16 divide with 16, so we try to find the answer will be 0.26. Alright, so this is the answer that student should write. Alright, so we move on to the next question. So the last part, the how to determine the empirical formula of less reactive metal. Please remember, less reactive metal, the metal like copper, all right, or lead. All right, so this less reactive metals, we will determine the empirical formula of less reactive metal by heating the metal oxide with dry hydrogen gas. All right, example, copper 2 oxide is heated with dry hydrogen gas, so we will get copper plus water molecule. And for example, let's say we take lead 2 oxide heated with dry hydrogen gas, so we will get lead plus water. So please remember this type of reaction. All right, so in this reaction, so we need to produce hydrogen gas. The hydrogen gas can be produced by reacting by taking acid react with metal, and please remember the metal should be reactive metal. It can be zinc or magnesium. So we will get salt and hydrogen gas. For example, let's say I'll take a magnesium, react with hydrochloric acid. The formula of hydrochloric acid, HCl, react with magnesium, so Mg. So we will take out the ion Mg2 positive. So here I take hydrogen ion, chloride ion. During chemical reaction, magnesium join with chloride, so I put MgCl. I take the 2, I put here. So when we see hydrogen ion, so we make it hydrogen gas. So we erase all these. Alright, so we try to balance the equation. So I need chloride 2, so I put chloride 2, hydrogen 2, hydrogen 2. This hydrogen gas will be produced. So here, if they ask what is the name of the acid W, so please put hydrochloric acid. The metal, please remember to put reactive metal like magnesium or zinc. And we will get hydrogen gas, and at the same time in the apparatus, we have oxygen gas. So here the mixture of hydrogen gas and oxygen gas. Alright, so we need to remove the oxygen gas, so the mixture of gas will be flow through anhydrous calcium chloride. So if in the exam they ask what is the name or function of anhydrous calcium chloride, please remember to dry the hydrogen gas. Alright, so once the hydrogen gas is flow, we still cannot heat up the combustion tube because we have still oxygen present here. So we have to allow the hydrogen gas to expel out all the air from the combustion tube. So here we have an opening, so we have to wait for a few minutes. So then we have to use the burning wooden splinter to test the presence of oxygen. If pop sound is heard, air still present. If let's say we have a blue color flame, hydrogen flame, that means air is absent, so we can light it up or we heat it up the combustion tube to get the result. Alright, so we check all the questions. So write down the chemical equation. The main chemical equation, we take copper 2 oxide, so this will be copper. Alright, please remember this will be copper 2 oxide. The copper 2 oxide reacted with hydrogen gas, dry hydrogen gas, to produce copper and water molecule. Name the acid, so I take hydrochloric acid, or we can take sulfuric acid also can. Magnesium and zinc. Please take reactive metals. Alright, so reactive metal like magnesium. Write down the chemical equation to produce hydrogen gas, so it's given here. State the function of anhydrous calcium chloride to dry the hydrogen gas. State safety 2 precautions, two safety precautions in this experiment, and explain your answer. So before we do the heated up the combustion tube, we must dry the hydrogen gas. The dry hydrogen gas must pass through the combustion tube for few minutes to remove all the air, because the mixture of oxygen and hydrogen gas will explode when we lighted up the combustion tube. And we must ensure the hydrogen gas is continuously experiment. This is to ensure the air does not enter from the opening here. So, and this may cause an explosion. Why we need to cool in the stream of hydrogen gas? Why we need to cool the product in the stream of hydrogen gas? This is to ensure the oxygen from the air does not oxidize the hot copper to form back copper 2 oxide. How do we ensure all copper 2 oxide has been reduced to copper atom? So this process, we repeat the process of HCW. Heating, cooling and weighing until a constant mass of copper is obtained. Alright, so if let's say the result is given, we try to find the mass of copper. How to find the mass of copper? We cancel the combustion tube, we cancel the porcelain dish, and we cancel the porcelain dish, so we will have the mass of copper. So we take 60.71 minus with 54.31, so we will get 6.40. How to find the mass of oxide atom? So we cancel the mass of combustion tube, porcelain dish, we cancel copper, so we will have oxide. So 62.23 minus with 60.71, we will have a mass of 1.52. So the unit I put here. How to find the number of mole? We will take the formula mass over molar mass. So please use the mass over molar mass. So we will already have 0.1. Then we find the ratio and we determine the empirical formula. Look at this question. Alright, so they give the experiment setup to determine the empirical formula of less reactive metal from its oxide. So suggest a metal oxide that we can use here. So we suggest copper must put this 2 oxide, copper 2 oxide. Explain your answer. So answer copper. Copper is less reactive metal than hydrogen gas. Alright, cover all the revision from chapter 1 until chapter 3. Alright, so that's all from me. Thank you very much. We meet up in next slot. Take care. Bye bye. See you all.